Hey everyone, and welcome to the July 2021 Gio Community Call. Our agenda today is going to be some project updates from Elias and I, a presentation on the Photon RSS Reader by Vladimír Magyar, and then some dynamic list state management from me again. So I'm gonna turn things over to Elias.
So yes, I finally got the CPU fallback implemented properly and relatively efficient. So I sent you all a message on the mailing list. I'll just copy the link here in case you haven't seen it yet. So basically, I have had this is for the compute renderer, which has been on the way for quite a while, and is still slated to be first the default renderer at some point, and then hopefully at some point become the only renderer, which means that that I can throw out the old renderer. But first, before it can do that, I have to fix some bugs, which I also wrote about in this announcement. But most importantly, there lacked a way for the devices that supports the old renderer but does not support the new one, at least not on the GPU. And for that, I did a CPU fallback. What I didn't want to do is rewrite something for the CPU just for those devices, which is both maintenance overhead and is prone to bit rot, because how often do you run on the device, Gio on a device that does not support compute renderers and so on. So my idea has been all along to compile the compute shaders, which is meant for GPUs, and compile them for CPUs. And that's where the project Swiftshader comes in, which is a Google project. Just find a link here. A Google project that emulates a Vulkan driver in software. So one of the many things it does is it can compile a Vulkan compute shader meant for the GPU to whatever host it's running on. So Swiftshader is meant to be linked into your projects. So if you have something like Gio actually that needs to run everywhere, you would typically link in Swiftshader to have that capability on devices that do not have proper support for whatever you need. However, I didn't want to add on Swiftshader, which is a relatively large C++ dependency to Gio. So my idea was to change it to, instead of runtime compiling these shaders to CPU binaries, an assembly or whatever you're going to call it, I wanted to just make it output object files. So a bit like having assembly code in your Go packages that is then linked into your project during Go build or Go run. And that succeeded sometime in the spring. I successfully hacked, I would say, Swiftshader into outputting its internal compilation. So I pretended to be a Vulkan client using it for CPU emulation of compute shading, but instead of actually running the shaders, I got it to dump whatever it generated as an object file, an ELF object file to disk. And with a few more hoops like that, you can actually have those object files linked into your Go project. I'll just see if I can find. So this is the main project that runs Swiftshader in this hacked mode, outputs the object files for a compute shader, and finally has a very small runtime to actually run these shaders, allocate the memory in the correct alignment, initialize images, and so on. So you need a little bit of runtime around it, which is written in C. And that runtime combined with the binaries are then used by one of the commits I did, which is called add CPU fallback. And basically, there's the end result is that there are very, very little difference between running these shaders on the GPU versus running it running them on the CPU, except for performance, of course. And all this I got working as a prototype on AMD 64 a few months ago. So since then, I've been working on making the CPU renderer efficient enough to actually be useful, because the main target for me was low-end Android devices, which not only don't they have the GPU support, they only have very, very slow or weak mobile CPUs. So that's what I finished most recently, which is, I think, the most interesting part of this on this major update, is I added a change that can detect, that can more or less automatically layer your UI. So I have an example in the commit. I can see if I can find it. So it's yeah, there we go. So in this commit message, there's an example of a UI very much like the kitchen example, where you have a progress bar in the middle of it. You have a lot of UI content before the progress bar, and you have a lot of several UI components after the progress bar. And what this automatic layering does is that in the first frame, it just says, okay, everything is a layer. So we'll just hope that nothing changes until the next frame, which is, of course, unrealistic, but it does save texture memory relative to have all your drawing commands split out and separated. Yeah. So first frame, everything is in a layer. But as soon as you render the frame where only the progress bar moves, it knows then that it can layer it can have one layer for everything before that progress bar is rendered, one layer for the progress bar, which is the one changing, and one layer for the rest. So which is 3 layers. And then for the third frame, if the only thing that changes is the progress bar, you can reuse very, very quickly by just copying the first layer and the third layer, and only compute render the middle, which is the progress bar. And that makes it so that, at least on my Pixel 1 Android phone, that the compute fallback is actually, it's not great, but it is workable, and you can press buttons without waiting too long and so on. So it's useful and usable, which is at which point I thought, okay, this is a good first release for the CPU fallback. And I did some more optimizations, such as making sure that if a layer is just moved by an integer offset, which is very typical for scrolling, you can still reuse layers. So it's not like when you scroll, you have to redraw everything, which kind of makes sense if you just look at it. But it's not the way I did it first is that I compared drawing operations and that they have to be exactly the same. So scrolling doesn't ruin the caching. What else doesn't ruin the cache? Yes, and of course, comparing operations for equalities is expensive if you have large paths, clipping paths, such as for text. But I exploited the fact that our text renderer or our text shaper, which converts text into shapes, clipping shapes, actually caches the shapes for reuse, so you don't have to redo them every frame. And I've exploited that fact to add a hash of the paths to that, so that when you build the clip paths, you also store the hash, which is needed for very quickly determining that the paths are not equal. And I also exploit the fact that if a macro is reused for clipping, I can just compare the macro keys instead of all the path data. So all in all, in summary, the compute shader should be much faster, especially for more or less static UI. And it has a CPU fallback, which is relatively performant. At least on my desktop, I almost can't notice the difference until you click the button that makes the entire, for example, for the kitchen, makes the kitchen example rotate very slightly, which means that all the layers are invalidated. And even that can be improved. You can say, okay, in the future, at least in the future, you can say, okay, we don't mind if layers not only for integer offsets, we can also say that layers that have their entire transformation different, such as a rotation or a scaling, still can reuse the cached layer, which will make the output of less quality than the hardware compute renderer, but would make it much, much faster and be reusable in those cases. And there's also an issue that it's only the most recent frame that is reused. So if you scroll down a relatively complex UI, you will have a performance hit while it renders the new content, but it will forget all the old content after a frame or so. So that's also something that can be improved. So it's definitely not as fast as it could be, but it's fast enough for our purposes right now.
So if I understand correctly, those automatic layering optimizations are used regardless of whether you're using the CPU fallback, right? Okay.
That's what took up most of my time, because for the kitchen example and the similar, it's very easy to do a quadratic lookup thing where you can't notice the caching, and but very quickly you reach a point where you spend quite a lot of time just figuring out where to layer stuff. And if that were so, I would only be able to enable it for CPU rendering. So I've done a few passes and failed experiments just to arrive at a reasonably efficient algorithm for diffing, so to speak, frames. So yes, that's what makes the compute share hopefully as fast, if not faster, than the old renderer.
So it's time to retest Sprig. Got it.
Yes, yes, it definitely is. So and with regards to what's still to do on my to-do list, so this CPU fallback only works on Linux and Android for several technical reasons, but there is no fundamental reason that the CPU fallback could not be done for Windows and Mac devices, Apple devices. For Apple devices, it may not be worth it, just because I suppose virtually every phone or device in use today have sufficient support for compute shaders in Metal, which makes the CPU renderer not very useful, except for perhaps tests, automatic testing, and so on. For Windows, there's the usual problem. It's probably even easier to make to get to work than Mac OS, maybe. But there is a big problem that we can't rely on at least until now, we haven't relied on the developer and user have access to a C compiler. So there's the usual, you have to avoid the CQO if you don't require a C compiler. And the CPU fallback runtime is written in C right now for several low-level reasons. And then there is 386. It only works on the 64-bit platforms and ARM 32-bit. I didn't get Swiftshader to output something that ran correctly on 386. I don't think it's probably some configuration or something I've misunderstood in my hacking. But I thought that, well, it's not really worth spending too much time on a platform that is I guess sees very little use in the wild. And then, of course, FreeBSD and OpenBSD, which should probably be the easiest to enable. I just haven't spent any time on it. So if anyone wants to do that, they're welcome to contact me if they need pointers. And of course, there's still the bugs I remembered. I mentioned in the beginning. Chris you have 2 outstanding issues. And I think Sebastian has a 3rd one. And of course, there's the actual porting of to Metal and Direct3D. So that's what's left before I think, okay, we can start thinking about switching it to be default. And then further down the line, we can think about throwing out the old renderer. Yeah.
That's a heck of a lot of progress.
Yeah, it's also been quite a while. I haven't had much progress to show for the past few months because I've been working on this problem. But so everything comes together today. There's also this is slightly, I wouldn't say slightly, but a big motivation is the Tailscale client running on Android. They have an open issue for low-end Android Go devices that just displays a black screen when running the Tailscale app. So for those, this release today almost fixes their case. There's also the problem that for very, very low-end devices, they don't even have support for sRGB, which is the color space that we're rendering in. So I expect and hope to have a workaround for that as well. And when I get that, or hopefully get that to work, we will have Gio running on everything that supports OpenGL ES2, which is basically, and we can run, I suppose we could port Gio to, say, the X11 Xrender extension. At this point, we wouldn't even need support for shaders, programs running on the GPU. We would just need a way to upload images to the graphics API and then blip them together, hopefully with sRGB support. So at that point, if the sRGB dependency is loosened to be an optional requirement, then I would expect, with a bit of work, of course, perhaps for strange platforms, that Gio could be ported to almost everything.
Well, that's awesome. Any questions? Okay. Well, you might have noticed that I said that we have a presentation from Vladimír, but he is not here. He couldn't make it today, but he did. Oh, Lucas has a question. But he did provide a recording of his talk that he would like us to play instead. So I'm going to get that set up. Elias, why don't you talk about this?
I'll just prepare a very small patch for him. It's not possible yet, so what I'll just do. So Lucas, what I wrote, yes. So this patch does two things. It disables the float render targets, which is required for the old renderer, so that the new computer shader is forced on, or you could just use the Gio renderer equals force compute. And the second change disables compute support on your device, so the computer renderer is forced to use the fallback. Okay. The reason I don't just to say I haven't added I may add an environment variable to force the CPU, but the reason I haven't done that yet is because environment variables do not transfer to Android devices. So when I test on Android, I have to do this kind of hacking anyway. So for me personally, for testing, I don't consider the environment variable override a good solution.
I suppose you could always do the, like no Wayland, no X11 build tag kind of thing. But
yeah. Originally, I hadn't envisioned that the default wouldn't change for so long. So maybe we can do the CPU fallback as a tag, and then because very soon the default should switch to the compute renderer. In which case we would need a tag for activating the old one. Yeah, tags are a good idea, definitely.
Okay. Let's hear from Vlado.
Hi everyone, I'm Vlado, and I will show you my RSS reader named Photon. But first, something about me. I am a programmer. I write mainly backend services for clients that cannot fit their data into spreadsheets. But I like to write little CLI tools. I love the Unix philosophy, and I use Go for the last 5 years or so. Everything began when I started to care about my online privacy more, wanted to de-Google myself, and with email, calendar and photos it was relatively easy, but I wanted to view my YouTube channels, the latest YouTube videos from my subscriptions. Then I found out that YouTube has RSS feeds for its channels, and you can play videos with MPV, which is a cross-platform media player which uses YouTube DL, which is a tool for downloading videos from YouTube. Then I wanted to use some RSS readers, but for example, Newsboat is a great RSS reader, but it's only terminal based, and I wanted to view the thumbnails of the videos. Then I found the Fluent Reader, which is great. It looks great, it shows the thumbnails, but it's written with Electron, and I don't want to run something which uses Electron on my computer. So I decided to write my own RSS reader, and I wanted to use Gio for it. I had an eye on Gio for a long time. I wanted to make some project with it. The immediate mode GUI sounded great and makes much more sense. And it is written in Go, it's multi-platform, and I followed Elias' work back when he made Go Mobile, and that was it. I think that Gio was the best choice. It must be great. So, Photon is by the Unix philosophy, a RSS viewer, not a RSS reader. It doesn't manage your links or your feeds for you. You can give him a list of links for your feeds, and it will show you the feeds. It downloads the feeds, runs workers for downloading the thumbnails, and shows it to you. It has a Vim bindings, so HJKL, Control D, Control U, and you can show the article with Enter using a package called Readability, which extracts the header, the top image, and the main text of the article. That was the motivation for writing the rich text package, which is now in GioX, but now Chris has made it better. He refactored it and made it more Gio-like. So that was a great collaboration. But you can also download or generate the RSS feed for yourself. I've written a small tool called Red, which you can write some config files with CSS selectors that will generate for you the feed data. So you can download and parse the site, and Rat will generate the RSS feed for you. This can be fed directly into Photon, and he will show you the content. Also, Photon is mainly used for for media, for YouTube, for videos and images. So Photon uses YouTube DL, which is a tool for extracting the media URL, and by the content of it, if it is a video or a image, it will show it to you in MPV or EMV and automatically run it. So you can run a YouTube channel URL and just Control Enter. It will get the
Time to start. Welcome to my broadcast on this.
It will get the media link, it will download it and check the content type and then run MPV. So using Photon is just by setting the arguments as the feed URL, or you can write a file with comments and so on, and you can see all the subscriptions that I have. It can also be used by Odyssey.com, YouTube, or you can write some command like ret that will run the command and parse the output from it. Also, Photon can detect torrent files or magnet links, and it will automatically run MPV with BTFS, which is a great extension for MPV, which downloads the torrent file and begins to stream the video to MPV. Okay, so that's it. Oh, and one more thing. I wanted to make more of things to do with Photon, but I wanted to be the Unix philosophy, so I didn't want to make much of the things in it. So I thought I can make Lua extensions where I can define new things to be done. Lua bindings are done with some user scripts, and I done some of it, like the translate URL, which can get the YouTube channel URL and translates it to channel ID, the feed URL, so you can use directly the channel URL of the YouTube channel. Also some cards and autoplay. It will play one by one the videos on the screen. So you can do pretty much everything. I made a red YouTube search that will search the videos on YouTube and generate RSS feeds, and that is put to Photon directly, so you can search for videos, and it will be shown in Photon directly, and you can play it. It's great. I use Photon as my daily driver, using it for Reddit and all sorts of things, and it will show you the text of the articles, and it's much more speedier than using the web or a Electron. Okay, so that's it. I hope you liked it. Bye.
Okay, so that's Photon. Seems like a pretty sophisticated Gio application.
Very impressive.
The Lua extension took me by surprise, because I wouldn't, off the top of my head, it's difficult for me to figure out how to do that in a way that wouldn't make me rip my hair out. But yeah.
The integration?
Yeah, the integration. I mean, I assume you have to go through CFFI and yeah, I don't know. I guess I haven't done it. Maybe it's easy. Maybe it's awesome, but I haven't touched it. Okay. Well, I wish Vlado could be here to take any questions, but as he couldn't make it, I would say direct your questions to his repo. Actually, I don't know if he's set up a mailing list. Let me go to his source set and see if he has any contact info. Oh, he does. Yes, here it is. So if you would like to ask questions or provide commentary on Photon, just put his mailing list for that in the chat. So next up is me, I suppose. Okay, so I'm going to talk about dynamic list state management, and that's a whole bunch of word salad. But what I mean is, in Gio, we have this cool party trick that we do, and we do this in like the immediate mode UI document that Elias has on the website. We can take a layout.list and we can give it some absurd number of elements, like 1 million. And then inside of the function that lays out each element, we just take the current index and use sprintf to turn it into a string and make a label. And we've just allocated this crazy huge list that we can scroll through, but it has almost no state, right? And that's really cool that we can make something so big and yet so stateless. But it doesn't work that way when you start getting into stateful things. Say if we wanted to build a Slack client in Gio, and we have a channel with, 1 million messages of history. Maybe that's absurd, but we have a channel with a lot of history, and we want to show that in a Gio list. We cannot get all of that data in memory. It's not going to happen. And so at some point, you need an abstraction that lets you take a logical, very long list of content and load a sub-region of that content, and then just kind of scroll that sub-region of loaded content across the larger abstract list of everything. And that larger list might be infinite. But since memory is finite, we need a way to achieve that. And so far in Gio, to my knowledge, we don't have one. So one of the things that I've been doing in my new work for Plato team is that I have been building out some types for this very thing. So this problem is complicated, not just because of the data structure side of things. I need to manage a slice of content out of a larger thing. That's not too terrible. But it's also complicated because loading from your infinite list or loading from your larger list is almost certainly going to involve blocking I/O. You're either going to be loading it from disk, from a database, from a network, but something that will take some real time. And because of that, it's not something you can do on the layout Go routine. It's going to make your UI stutter and you're going to drop frames and it's going to be awful. And so the solution to this needed to be carefully designed so that all of that work would not happen on the layout Go routine, and that none of the interactions between the layout Go routine and the Go routine that's doing all this state management would cause the layout Go routine to block. So this diagram here represents kind of the life cycle of data that we've come up with so far. And Jack Mordaunt has been helping with this, but he couldn't make it today either. So if you imagine this rectangle on the left to be your source of truth, let's say this is all the chat messages in your database, and each of these single letter messages represents a much larger piece of content. We have 6 hooks, 6 functions that you provide our list manager so that it can do this complicated job. And we're going to see how each of those 6 hooks is used within the life cycle of the data to bring it to the screen. So we start off with, let's pretend this is a database, and we have the loader hook, and its job, surprisingly, is to load content from that database. It has 2 parameters. One of them is the direction it wants to load content in, before or after, and the other parameter is the identifier of the piece of content that it wants to load relative to. So it's the thing that we're loading before or the thing we're loading after. All of the elements managed by this system implement a common interface called list.element. And the only requirement of a list.element is that it have a method called serial that provides a unique identifier for that element. And that it's really important for that identifier to be unique. And we can talk about more. You'll see how it's used later on. The very first time that loader hook is invoked, there's no data in the list manager. So we provide the special no serial as its relative to parameter. And that's how the loader hook knows to load whatever data should come first. But after that point, it will load based on where the scroll position is. So once we have some data from the backing list, we use the comparator hook and we sort it. And for your very first load, that doesn't really matter. But as you accumulate state within memory, within the managed list, we have to make sure that it stays coherent. So we sort after the load. And that comparator is kind of the standard library sort.interface style thing, where it's a function that accepts 2 elements and returns whether the first sorts before the second. So all of that is pretty straightforward. You would think that we've loaded some data and we've sorted it, so we're ready to use it, right? But we have this extra step, and this extra step is a little odd. We call it synthesis. It is implemented by the synthesizer hook. And at first, it is difficult to see why this exists. The synthesizer hook gives you an opportunity to transform managed list elements before they are presented. And it runs in this separate state management go routine, which means that these transformations can be expensive. And the reason for that is if you think about, say, a chat application, like a hypothetical Slack front end, in Slack, anybody can change their username and their avatar at any time. And so if we had that data baked into the kind of raw state, if the letter C here represented a structure that had username and avatar image data and the message, and then that user changed all of those attributes, we still have them here in memory, right? So we're going to be displaying the wrong username and the wrong avatar because we have a copy of those things. But if instead that raw state just contains an immutable identifier for the user, during the synthesis hook, we can then perform whatever lookup we need to resolve dynamic attributes of the data, like their username and their avatar and anything else that might change. Another thing you can do in the synthesis hook, you'll see that elements X, Y, and Z have popped in out of nowhere. You can actually insert new elements. So the reason that you might do this is in a chat context like Slack, when days pass between messages, you want a date separator to appear that says, stuff below here occurred on July 27th. Stuff above here occurred before that. So the other things that synthesis can do is hide elements. So you'll notice that E doesn't actually make it through the synthesis hook. So if you're looking at a list of, files and folders, and you have a search field, so you want to filter them by some property, the synthesis hook gives you a way to actually hide that element. It's still within kind of the managed state of the list. It still exists within the list, but it's not currently going to be presented. And because that filter logic may or may not be complex, you can do it in this state management go routine so it doesn't block layouts. So then once you've actually got this presentation state slice, you send it on a buffered channel, which ensures that it can send in a non-blocking way. And then we can immediately invoke the invalidator hook, which, surprise, invalidates the window. So a layout pass should come soon after that and pick up this new slice of state. The layout conditionally receives on the state update, so it doesn't always block there waiting. And the next thing is trying to allocate any widget state necessary for these elements. So if C is a chat message, and we're thinking about like the Slack interface, you can right click on chat messages and there's a context menu. There's a little reaction button if you want to put an emoji reaction there. When you hover over them, a little toolbar appears, tons of buttons in there. All of those things are going to need clickable state and context area state and many other kinds of state. And so the allocator hook allows you to look at an element's concrete type and allocate the appropriate widget state for that. And then this list manager will actually take care of the life cycle of that state for you. If you ever scroll so far away from element C that it gets discarded from the region of the list we're looking at, we will also deallocate its widget state for you. So then the final hook is the presenter hook. It kind of zips together allocated states and kind of the raw list elements, and it's responsible for returning a Gio layout function, which will be used by a list to render or to lay out and present your content. So that is all 6 hooks, and I know that's kind of a whirlwind, and it's also abstract. So let's make that more concrete. So this is an application that is among the simplest things I could think of that would meaningfully use this system. So this is an infinite horizontal image scroll. And we'll just look at the interesting parts. So image element is a list element. It satisfies the list.element interface that the list manager works with. And to do that, it just needed this one method that returns a unique identifier, a serial, for this element. Serials are strings under the hood, and that is so that applications can encode arbitrary semantics in them as long as they're unique. So you might use a UUID, you might just use an integer. There's a lot of possible things you could use as a convention for what your serials are. The loader hook for this application takes the direction and the thing you're loading relative to and tries to produce a slice of list elements from that. And the way that we're going to do this in this particular application, we're going to be iterating over an infinitely long, or I suppose a max int long array of images. And rather than storing any of the state for these images in some kind of backing data structure, every time the loader is asked for an element, it's going to make a new one. So we're going to start with serial of 0 if the relative to parameter is not an existing serial. So this will only happen the very first time the loader hook is invoked. And otherwise, we're going to get an actual serial, and we're going to convert it back to an integer, and we're going to either decrement it or increment it based on whether or not we're loading before or after that element. And then we're going to go to Unsplash, which is a great place to get permissively licensed imagery. And we're going to pull a random nature photo, decode it, and return a list.element slice with just that one element. The comparator hook, which sorts elements, is just going to convert our serial to an integer and do, greater than, less than comparison. The synthesis hook for this is very simple. It's kind of a no-op. We take the current element and we just return it inside of a slice. But we have the previous element if we wanted to do some look behind sort of stuff. And there's an iteration of this API that's coming where you'll also get a look ahead next element, but that's not in main at this time. Our allocator is really easy because all of our elements are the same concrete type. We're going to allocate paint.imageOps for each of them. And then our presenter is also really easy. It accepts a list element and the state from the allocator, and it constructs a widget.image that will contain and returns its layout function. So using all of these together, we construct a list.hooks and we provide it with these hooks. The invalidator hook is just going to be the invalidate method of the window. We construct a list manager with 10 capacity. So the total number of elements that it will actually manage in memory is 10. And we're also going to make a ticker that's we're going to use it to dump memory statistics the size of the heap every second, so that we can see that our memory use is not growing without bound. And then our Gio event loop is very simple. Every frame event, we make a context. We're going to lay out a material list. The interesting component of this is over here. So when we go to provide the size of the list to the material.list, we actually invoke a method on the list manager called updatedLen, and we pass it a pointer to the list. The reason we do this is because the list manager needs to be able to handle the case where elements have been added or removed from the underlying list that it's managing, such that the overall list length has changed. Because when that happens, the position of the list is suddenly wrong. You know, you were looking at element C, and then we added a bunch of elements at the beginning. So the element at that same index is now much earlier in the list. So if we don't do anything, your viewport on the list jumps a lot. It's really jarring and horrible. So what this does is it rewrites the list position to be consistent across state updates of the content that you're looking at. So it's really important that you use this method to provide the length of the list. And then the layout function on the list manager has the right signature to be used as a list element. So let's look at that actually in action. So we have a pretty image of trees. Let me move this. Okay. And we're going to scroll some, and they've served us the same image twice. Here's a different pretty image, lots of pretty nature. You'll see that as the scroll bar approaches the left edge of the screen, we fetch a new element, and so it jumps back to the right a little ways. You'll also see that it has stopped getting smaller because we've already hit our capacity of 10 list elements. And so now as we go left, elements to the right are being discarded. And you can see our heap size. I mean, it goes up and it hits some higher watermarks, but it is bounded because the elements that are discarded, we're discarding their image data. Now, I'm going to show you a more complicated application that takes advantage of this. So this is the overall project that I've been working on for the last month on behalf of Plato team is actually a suite of open source chat widgets and components for Gio to make it easy for anybody to build chat interfaces. And so what you're looking at here is our kitchen example of those components. So we have this chat history that can show images and all kinds of other things. And it has infinite, well, not infinite, because the amount of pre-generated data is finite, but we can scroll backwards a fair ways. We have like image modal previewing, and you can send messages, and there's some other stuff. It's got some nice like responsive design, and this is a 9-patch skin underneath this image, so that is a raster image that'll stretch around the content. There's another one in here somewhere. I don't know if we'll see it in this chat. There's a goofy looking, yeah, there it is. There's a hot dog that stretches. But anyway, this application is closer to a real world chat that takes advantage of this list manager and does much more complex things. Its hook implementations are significantly more complex. And so this is the repo for that project. I'll put it in chat here. There's also a mailing list and an issue tracker if you are interested in consuming that or participating. The thought is that once these components are kind of polished enough and stable enough and proven to satisfy the use cases they're designed for, they may end up moving to other homes. They may go to GioX or something like that. But they're over here in this little repo on the side because they evolve very quickly. Jack and I work on this repo every day. So we didn't think that putting them in GioX in this kind of eternally changing state would fit. Because I don't think people expect GioX to break every day, just once a month or so. Yeah, so that's what I've been working on, and I think it's in a state where it should be useful. Its API is not done though. There's definitely some things that we're still doing, and we have plans to do more. Yeah, any questions? Elias?
So I have two. One small question is you mentioned that you may in time add the widgets to GioX. I was wondering whether you would be interested to add just the kitchen chat program itself to GioExample.
I mean, sure, we can do that.
I think it looks great. It demonstrates a real world typical use, and it has a lot of components. It's a much better version of what I wanted to display with the age-old what is it called, Gophers example.
Okay.
So that's just an idea
yeah.
if you think so, and you have commit access to it, so it shouldn't block you too much. But of course, if you want to wait until it's more stable or something like that, you can do. But I think it definitely belongs into GioExample, especially because it sounds. You mentioned that it was your kitchen example, so it sounds like it doesn't have too many outside dependencies outside of just drawing a chat-like interface.
Yeah, we have a couple. I'm trying to remember. Yeah, we have a lorem ipsum generator and
sure, but you don't have. It doesn't sound like you have too many, say, requirement for a login or a token or.
Yeah.
Like so you have actually have yes, you have real data, which doesn't rely on some token. So compared to the Gophers example, which requires a GitHub token on the command line if you want to use it more than just a single run, because the anonymous quota is so low.
Yeah, I think that Unsplash has a quota too, but we don't generally hit it.
Mm-hmm. That's good enough. That's good enough for me.
So.
Yeah, I had a similar question. I wanted to ask why not use interface, the empty interface for list serial.
Empty interface is actually an interesting idea. At the time, I thought it needed to be early in the design. I thought it needed to be a concrete type. But really, it's just anything that is unique can be compared for equality. Mm-hmm. So I actually think we could change that, and it might make more sense to do that. Yeah, I'll have to think about that some, but I do think it could probably change. As far as why not make it like an int64 or a byte slice. I tried a byte slice. That was my first idea because I thought it probably needed to be arbitrary length. I didn't want to dictate too much to the application, too much of the application design, because I thought about, decentralized use cases where you don't have a single monotonically increasing identifier for something. You might need to represent a hash of its content or whatever. There are all kinds of ways that you can assign identifiers. So I wanted to be flexible. The ergonomics of a byte slice really sucked in terms of what you actually had to write in order to manipulate the serials, but empty interface with application defined content would work.
So it would be cheaper to convert, and especially if you naturally have a struct or something to describe your key, and the Go runtime takes care of incomparable types. You will just get a panic for that. So you won't get in a situation where the keys are not somehow incomparable.
So yeah, I think that's a great idea, and I might do that.
So another one I had is, can I see the hooks again for your example program, the carousel, and go up to the, I think it's the one where you had the list directions. Yes, that's one. I haven't thought much about it, but it seems to me that you could simplify the logic a little bit for the special case of the initial element to have the direction being, for example, initial. Instead of, so you have one switch saying before do this, after do this, and list dot initial do this.
Yeah. Yep.
Again, then you can't, in this example, you probably can't share the A to I conversion. But if you do have keys as interfaces, then it may not matter that much.
Yeah, I think that would probably be better. There is actually a third value of list.direction already, so that kind of indicates no specific direction. So we could switch to that. I knew that if I brought it here, y'all would show me all the errors in my way. So thank you.
It may not eventually be a good idea, because for example, with the empty interface, you lose some of the type safety. Any value that you can be assigned to a list.serial variable.
Yeah. Well, so
you lose a bit of type safety by not having strings.
Yeah, I wonder, is it too far to make list.serial not the empty interface, but just a interface that has a method that, kind of declares intent to satisfy? That would give you compile time warnings, but at the cost of some maybe ugly assertion whenever you wanted to use it.
In my personal taste, I wait to do these kind of extra paperwork for developers until the need arises. In this case, it would be too many developers using too much time debugging a list serial which is not intended to be a list serial.
Fair enough.
But I would definitely like to see this kitchen example in the Gio example. It's a great demonstration of many features of TU and of course your widgets, and also a very quick demonstration that it is possible to write something of that complexity.
Well, cool. I will look into doing that. I think we're going to have to maintain 2 copies or something.
Or at least somehow mention it, make it discoverable from the front page or something. I think it's really, maybe replace the screenshot that is on GUI.org or something. I think it's one of the most pretty and general purpose examples I've seen, standalone at least, of GU.
Okay. Well, I'll figure out how to do that.
But don't make it too difficult on yourself, of course. Of course, it shouldn't be a maintenance headache for you.
Yeah, I mean, we definitely love to make it discoverable. We just have to find the way that doesn't require periodically, or doesn't introduce a ton of friction. Having it in the same repo is just so killer in terms of being able to iterate
sure,
on the
sure.
API.
What we could do is do the same thing on the website. The website is prepared to go generate WebAssembly binaries of examples, even outside the website. For example, the front page kitchen example is runnable by clicking on it, and that's very, very easy to add new examples to. So we may even have an example page with just links to the different examples that can run directly from the website.
Yeah, that'd be good. One thing, that is the example that I mentioned in the to-do ticket. We seem to run out of texture memory with that example on the compute shader.
That's a known weakness of so the output can the number of layers, cached layers, can be as big as the GPU can handle, but the materials, which is the transformed images and the image atlas itself, are currently not multiple textures, so you can easily run out of space there. I had expected space to run out before you reported it, and it may have happened in some way that people haven't reported. So it's definitely something that I will be taking a look at.
Okay.
The reason I haven't done it is I'm more concerned about the GPU hangs and rendering glitches in general. So in other words, I know why you run out of space, or at least why it's very easy to do, whereas the hangs and so on are more important to correct. But I'm definitely going to fix the space issue before I make it the default.
Awesome. Okay. Well, any other questions? Hearing none, I think I'll stop recording. Thanks everybody for coming out.